Let's see if we can support Congress. We know we're over here, which means we know the curve for commercial volumes above TV volumes has shifted to the right. Has it shifted so far to the right that it's significantly higher? Good. So is the curve so far to the right that it's in? I don't know. I can't do that kind of math in my head. Let's run the machines and figure it out for ourselves. So we're going to run a t-test. Yes, that's the distribution we have to use. We decided that already. So that's the variable you want to test, or the distribution you want to test. Good. Tests. T-test. Beautiful. Boom. Mine's still set up from class last time, the speed limit data.
Oh wait, what are we doing?
A t-test. Just like the speed limit data, it's like the IQ data, same exact thing. So we're going to use data again, because we didn't bother doing summary statistics yet, so we're still going to use data. What's mu naught?
0.
It's 0, isn't it? It's the null hypothesis data value. And if this is called a matched pair t-test, it'll always be 0 in this case. It'll always be 0 in this case. We'll see another one in about 10 minutes. We'll run another test. Where's your data? What should you put for list?
L3. L3.
Very nice, very nice, very nice. It's in L3. L1 and L2, for all intents and purposes, don't exist anymore. You collapse them down to one. What's cool is you collapsed them down to one list and didn't lose anything in the process. Isn't that cool? That's pretty slick. So, L3, what's your frequency? Oh, I thought I'd get you guys. I can't. It's 1. Oh, not Y. 1. Oh, sorry. Yes, I just did the same. You got Y, didn't you? I got the exact. When you jump, this is a bug they never bothered to fix. When you jump between these two, do you notice how that A shows up?
Yeah.
You got to turn the alpha lock off. Just press the green alpha button and then hit 1. Yeah. Just when you thought you'd be done with that too.
Yeah.
And now? Yes, this is why we wanted to make sure we knew which direction we subtracted stuff. It is definitely going to be a greater than. It's definitely going to be a greater than. Beautiful. Do you guys like calculate or draw better? We do mostly draw. We've calculated once or twice. I'm going to check one thing before I go anywhere. Yeah, I'm going to turn all this crap off. We modeled rock, paper, scissors in 105 yesterday. It was fun. We calculated how many games it would take to whittle the class down to one person. And we nailed the average almost every single time. And it's not surprising, it's statistics. So here we go. There comes your t-curve. We're looking for area on the right. That's the greater than. Now we're going to see how much area we get. Oh!
Okay, I just want to make sure I got area on both ones.
Then change the sign to greater than, not does not equals. When you go back to the test again, Frankie, just run the whole, go back to stat tests, t-test. Make sure you grab this sign. Okay, you've now answered, I think, steps 7 and 8. Yes, the test statistic with its variable and the p-value. And the p-value. So, what's your test statistic? 1 t equals 1.09, 1.0878, whatever you want to write down. So that's about 1 what?
Standard deviation.
Oh, good, sorry. Yes, absolutely, Jolene. About 1 standard deviation above average. Do we start going, oh, when we're 1 standard deviation above average? No, because that's like a minor wiggle off to a side, right? And sorry for the noise. And to go with that, look at the p-value. It's small or big? It's big, and when I say big, it's over 5%. So those two things agree with each other, right? A small number of standard deviations corresponds to a large p-value. P-value is a measure of agreement of the hypotheses. A big p-value, this is big. I know it's 14%, which doesn't seem that big, but it's over 5%, which is what we're using, correct? Over 5% means which hypothesis do we agree with? We agree with the null, don't we, when it's big? The small p-values are the ones that say, as Danielle, I believe it was you, small p-values means that something has changed. Big p-values mean that nothing has changed. So the big p-value in this case of the 14% or 14.5%, nothing has changed, which means that we were coming into this test doubting Congress, right? Congress was saying something has changed, commercials are louder. Our data says it doesn't look like they are. So how would you make the conclusion? It does not appear that the average commercial volume is louder than the show, or commercials are louder than shows. Boom! Could we be wrong? We could be wrong, yes?
Yes.
It would be a type 2, it would be a false negative, yes?
Yes.
And looking at it graphically, although your TI can't do this, this is one of those ideas I had riding the bike up the hill a couple weeks ago. I want to build you an Excel spreadsheet that lets you calculate these too. We could be wrong in that maybe the curve is way over here, and we just landed significantly far to the left of it, which would be a type 2 error, right? It would be an outlier on that curve versus an outlier on this curve. An outlier on this curve is a type 1 error. An outlier on the other curve is a type 2 error. And that's the only kind of error we could have made with our data results right here. So we could be wrong. But it sounded like most of you could live with a type 2 error more than a type 1 error, yes? That's what it sounded like. There was one person that voted for type 2 as the worst case, and the rest of you voted for type 1. Well, okay. We don't have to rate. Cassidy, go. No, don't be sorry, go.
So is type 2 saying cursors are not louder when they are?
When they actually are. Because that's what we just said. We just said it doesn't look like they're louder, correct?
Oh, okay.
That was our, no, you got it now. You got it now, because we just said it doesn't appear the commercials are louder. The way we could be wrong is they might actually be, and we missed it. Fair? I want to come back to that point in about 30 seconds, but Alan, go.
Just curious, so low p-value means you're rejecting the null hypothesis.
That's absolutely correct.
Okay.
Yes, low p-value means you have to believe this guy,
Okay.
because you can't believe this guy. You reject it. I love that word, even though it's kind of very traditional. I wear a tie today, it's perfect. So yeah, low p-value, you reject this.
Okay.
Yeah.
What's weird is a high p-value, what logically would you think, using that same language, what would you have to do?
You have to fail to reject.
That's exactly what it is. You fail to reject that. Isn't that weird? Because it almost makes sense. You reject this. If with a big p, that would, because if, a small p-value, you reject this. So a big p-value, you'd think it would be like, oh, you reject this. But it's actually you failed. Every claim traditionally is made on the null hypothesis. It is weird. That's why step 9 exists on your template, because I want you to put it in English words. It does not appear commercials are louder. Does that make sense? Now, I did some more digging after I crunched it myself, and I found some stuff that you might be interested in. You might not. I don't know. Maybe you are, maybe you're not.